Hi everyone. In this lesson, we're going to talk about special right triangles, and this is also review from geometry, but these triangles are going to come up a lot as we move forward with trigonometry, so I just want to make sure that you have a good understanding of the special right triangles. So there are actually two special right triangles. The first one we refer to as a 45, 45, 90. And that refers to the angle measures in the right triangle. And so if you guys remember when we started talking about trigonometry, we reviewed similar triangles. And remember, that's the basis for trigonometry. So the idea is the same here. All 45, 45, 90 right triangles are similar triangles. So that means that their side lengths are proportional, or they would all have the same ratio. And so also, if you think about Pythagorean theorem, in our 45, 45, 90, let's just say that each leg is 1 unit long. And in this case, the legs are the same length, because it's a 45, 45, 90 special right triangle. Well, if we were to use Pythagorean theorem to find the hypotenuse, we would have 1 squared plus 1 squared equals c squared. And basically, we would end up with 2 equals c squared. And then we would square root both sides. And the hypotenuse ends up being the square root of 2. So basically, if you compare any 45, 45, 90 right triangle to this right triangle, they would be similar, or the corresponding sides would always reduce to the same ratio. Okay, so we can use this to solve some of these problems very quickly. And so there's two relationships you want to remember. The hypotenuse would always equal the square root of 2 times the length of the leg. Because notice here, if we multiply square root of 2 times 1, that equals square root of 2. Now, to find the leg, we would need to reverse that. Or think about taking the equation we just wrote. The hypotenuse equals the square root of 2 times the leg. If we took that equation and solved it for L, we would end up with the leg equals the hypotenuse divided by the square root of 2. Okay? So those are basically your two relationships. The leg of a 45, 45, 90 right triangle is equal to the length of the hypotenuse divided by square root of 2. And the length of the hypotenuse is equal to the square root of 2 times the leg. And again, we can use those for any 45, 45, 90 right triangle. So let's look at some examples. If you look at number 1, we're given the length of a leg, which is 8. So to find the other leg, that's very easy. That would also be 8 because the legs are congruent. And then to find the hypotenuse, that's also very easy because, again, it's the length of the leg times the square root of 2. So y would equal 8 times the square root of 2. And that's all you have to do. Okay, let's look at number 2. This example is kind of similar. We're given the length of a leg, which is 25. The other leg, in this case, is y, so that is also 25. And then the hypotenuse, which is x, would just be 25 times the square root of 2. All right, now if we look at number 3, this one's a little bit different. This time we're given the hypotenuse. So I'm going to solve for x first. So remember, the length of the leg, which is x here, is equal to the hypotenuse divided by the square root of 2. And you could leave it like that, or you could rationalize your denominator. So you multiply by square root of 2 over itself, multiply straight across, and you get 19 square root of 2 over 2. Oh, my 2's look kind of funny. All right, so that is the value of x, 19 times the square root of 2 over 2. And since y is the other leg, it is the same value. So 19 times the square root of 2 over 2. So that was pretty easy. Okay, now let's look at a 30, 60, 90 special right triangle. So this is your other type of special right triangle, and again that refers to the angle measures. And again, the same idea is the same. All 30, 60, 90 right triangles are similar. Now, in a 30, 60, 90, the legs are not the same length. So often we refer to one as the shorter leg and the other as the longer leg. So this will help you with that. The shorter leg is always opposite the 30-degree angle. And the longer leg is always opposite the 60-degree angle. Okay? And the relationship works like this. It's all about the shorter leg. So kind of like we did with the 45, 45, 90. If the shorter leg is 1 unit long, then the hypotenuse is always double that, or 2 times the shorter leg. So it would be 2. And the longer leg is always the square root of 3. So if you just remember the 1, 2 square root of 3, that'll help you out. Okay, so it works like this. I'm going to start with the hypotenuse again. So remember that the hypotenuse is always 2 times the shorter leg. So I'm just going to call that SL. Okay? So let's say we wanted to solve for the shorter leg. If we took that equation and solved for the shorter leg would equal the hypotenuse divided by 2. Okay? So it's just the hypotenuse divided by 2. And then your longer leg in relation to the shorter leg is always the square root of 3 times the shorter leg. And my 3 looks a little funny, but it's square root of 3 times the shorter leg, which I'm just calling SL. All right. So let's look at how we can use this in the examples. If you look at number 4, in this case, we're given the shorter leg. So the shorter leg is 5. So I always like to start with the hypotenuse because that's the easy one. It's just 2 times the shorter leg. So the hypotenuse is 10. Okay, basically this is 10, 2 times the shorter leg. And then your longer leg, which is x, is just your shorter leg times the square root of 3. And that's all you have to do. All right, let's look at number 5. This one is pretty similar. 14 is the shorter leg. So the hypotenuse, which is x, is 2 times that, or 28. And then your longer leg, which is y, would be 14 times the square root of 3. Okay, now number 6 is a little different. This time we're given the hypotenuse, but that's okay. Start by finding your shorter leg. So all you have to do is take the hypotenuse and divide it by 2. So the shorter leg is 16. And then to find your longer leg, you just take the shorter leg and multiply it by square root of 3. And then you're done. All right, let's look at number 7. Again, we're given the hypotenuse, so start by finding your shorter leg, which this time is y. So 46 divided by 2 is 23. And then to find your longer leg, which is x, we just take the 23 and multiply it by square root of 3. So we get 23 square root of 3. Okay, on number 8. Now we haven't run into one like this yet. This time we're given the longer leg. Okay? Now, when you're given the longer leg, let's go back up to our rules. The longer leg is equal to square root of 3 times the shorter leg. So if you think of taking that equation and solving it for the shorter leg, you would take the longer leg and divide it by square root of 3. Okay? So actually we could add here, or the shorter leg is equal to the longer leg, which I'm calling LL, divided by square root of 3. Okay? Alright, so let's go back down. Okay, so we're going to take the 20 and we're going to divide it by square root of 3. And that would be our shorter leg, which is y. And I'm actually going to let you leave the radical in the denominator here. Okay, now to find the hypotenuse, we just take the shorter leg and multiply it by 2. So that would be like taking this and multiplying it by 2 over 1. And so that just becomes 40 over the square root of 3. And then you're finished. Okay, now if we look at number 9, 9 square root of 3 is actually the longer leg. So again, we want to start by finding the shorter leg. So we're just going to take 9 square root of 3 and divide it by square root of 3. So this is kind of nice because those are just going to reduce to 1. And so x is going to equal 9. And then to find y, which is the hypotenuse, we just have to take the 9 and multiply it by 2. And you get 18. And then we're finished. Okay, so now what we're going to do is we're going to take our two special right triangles and we're going to write the trig ratios for them. Okay, so I think my angle measures moved a little bit. Let me try to fix that real quick. That's okay. I'm just going to go back to full screen. Okay. All right, so basically we want to fill in this chart and we want to find the trig ratios for all of these angles. Okay, so this just got moved over, but this should be 30 degrees, 45 degrees, and 60 degrees. Hopefully it looks like that on the paper. Okay, so let's start with our 30, 60, 90 right triangle. Okay, so if we're finding the trig ratios for the 30-degree angle, if we label our sides, the 1 is opposite, the square root of 3 is adjacent, and the 2 is hypotenuse. Okay, so we're just going to use our SOHCAHTOA to find our trig ratios. So sine of 30 would be opposite over hypotenuse, or 1 over 2, which is 1/2. Cosine, which is adjacent over hypotenuse, is square root of 3 over 2. Tangent is opposite over adjacent. Now, initially you get 1 over square root of 3. Now, in this case, we are going to rationalize the denominator. And you end up with square root of 3 over 3. Because usually you see it in this form, square root of 3 over 3. That is a 3. Okay. Now, remember, to find the remaining trig functions, or the reciprocal trig functions, all we have to do is flip the first 3. So cosecant is the reciprocal of sine. So if we flip the 1/2, we get 2. Secant is the reciprocal of cosine. So actually, initially, that'll be 2 over square root of 3. But then if we rationalize the denominator, we get 2 square root of 3 over 3. And I'm going to try to squeeze that. That is a 3. I'm having trouble with my 3's. Okay, and then cotangent is the reciprocal of tangent. Now, if we go back over here, because this was initially tangent, and flip that, you'll get square root of 3 over 1, which is just square root of 3. Okay, now, let's go ahead and find the 6 trig ratios for the 60-degree angle, since we're on that same triangle. So if we switch to the 60-degree angle now, remember your opposite and adjacent are going to switch. So now square root of 3 is opposite and 1 is adjacent. Okay, so sine of 60 is going to be square root of 3 over 2, opposite over hypotenuse. Cosine of 60 is going to be 1/2. And tangent of 60, which is opposite over adjacent, is going to be square root of 3 over 1, and then you can drop the 1. All right, now let's find our reciprocals. Okay, so cosecant is the reciprocal of sine. Now, initially when you flip it, you're going to end up with this, 2 over square root of 3. But then rationalize your denominator, and you get 2 square root of 3 over 3. Secant is reciprocal of cosine, so that's easy. That's just equal to 2. And then cotangent is the reciprocal of tangent. And so you're probably kind of seeing a pattern here. But if we take the square root of 3 over 1 and flip it, we'll get this again. And then rationalize, and you'll get square root of 3 over 3. Okay. Oh, and you know what, you guys? I put those in the wrong column. These should all be over here for 60 degrees. So hopefully you use pencil and you can erase that, because I don't want to have to start the video over again. Okay. So let me erase these. Okay. Now let's go to the 45, 45, 90. Right triangle. And so here you can pick either 45-degree angle. It doesn't matter. Because basically your opposite and adjacent are both 1. And your hypotenuse is square root of 2. So again, if we find sine is opposite over hypotenuse. So initially, that's going to be 1 over square root of 2. But if you rationalize your denominator, you're going to end up with square root of 2 over 2. And usually you'll see it in this form. Okay, notice the same thing is going to happen with cosine. Cosine is adjacent over hypotenuse. But again, we're going to end up with the same value. And then tangent is easy. Opposite over adjacent, 1 over 1 is just equal to 1. Okay, and then to find our reciprocal functions, cosecant is the reciprocal of sine. Now I'm going to go back here and flip this, because you'll just end up with square root of 2 over 1, and then you can drop the 1. And since sine and cosine are the same, cosecant and secant are going to be the same. And since tangent is 1, cotangent is also 1. All right, so now we have the 6 trig ratios for our special angles, 30, 45, and 60-degree angles. We will actually use these values a lot, and you will come to know them and have them memorized as we get into the unit circle. So, all right, you guys, we'll practice this some more in class tomorrow, and I will see you then.